Shields family, we're right here at our house, our home that you guys have built. So we want to let you know how much we miss you. Get ready for your next review. I got a surprise for you if you go to sciencebuddy.net. I just dropped my new mixtape. You thought I couldn't DJ. So I got that for you guys if you guys want to peep that out. So we're going to take a quick little tour, go up here for some memories, little memory lane. So come follow me. Come on, guys. There you go. Familia, here we go. Now I want you to be totally honest with me, okay? So it's you versus me. I want to see if you guys can outnumber number of correct versus incorrect, okay? So we're looking at finals review 1, semester 2. So we're going to break each one down, all right? So we're going to go each category. We're going to start off with red, speed. So for 100 points, an object's distance and the movement per unit of time, what is it called? Speed. Not bad. What is the formula for speed? Answer is speed equals distance over time. True or false? Does this represent speed? Meters per AU, which is astronomical unit. Answer is false. It doesn't, because they're both measuring distance. Particular instance in time is called instantaneous speed. Pretty good. Calculate a person traveling 25 miles and an average speed of 5 hours. You can pause the video if you need to. 5 miles per hour. So remember, it's distance divided by time. So it's 25 divided by 5. Okay, so we took care of the red one. Now let's go for the next one. So Hector did an experiment on motion involving a toy car. After analyzing his data, he concluded that the object in motion was moving at a constant speed. What did Hector use to measure his data? A metric ruler and a stopwatch? A balance and metric ruler, a stopwatch and graduated cylinder, a graduated cylinder and a triple beam balance. So he's trying to measure data now, or used to measure data. A is your answer. It's going to be a metric ruler and a stopwatch, because remember, you're looking at time, which is going to be the stopwatch, and distance, which is going to be measured with the ruler. Maria plotted a graph of her data that she wanted to include as part of a report on motion. Her graph is shown below. What conclusion did Maria correctly make? The object did not display any motion. The object slowly increased its speed. The object changed direction as it moved. The object maintained a constant speed. So take a look at the graph. There you go. It's going to be D. Okay, and the way you know that is because notice the constant speed that you have here. Notice how if you're right here at time for 1 second, it's close to right here. If you look at it, look at your time right here. So almost 20. Okay, 20 is around here, so half a second. Okay, now you start to pay attention. You notice you're looking at a diagonal line. As soon as you have that diagonal line, it's telling you it's going to be constant, because it's not changing where it's going up or where it's going down. When was the speed of this moving object constant? Between 0 and 2 hours, between 1 and 5 hours, between 4 and 5 hours, between 6 and 7 hours. So what would you say? It's going to be D, between 6 and 7 hours. And the way you know that is because if you start here, remember, go back to what we just said, diagonal. Notice it's diagonally going straight up. What was the speed of the golf ball as it rolled down the ramp? About 2 feet per second, about 1 foot per second, about 3 feet per second, or about 6 feet per second. So look at the graph now. Your answer is B. So pay close attention, right? So if you look at it, here's your 1, okay? Distance divided by time is 1. Now you go to the next second, which gives you 2. Well, let me go back again. And right here, 2 divided by 2, it gives you 1 again. So as you're moving up, you'll notice that they're close to the same number that you're looking at. Number 5, Felipe made a graph showing distance versus time. What did Felipe plot on his graph? Was it force, work done, speed, or direction? Okay? So notice you're looking at graph showing distance versus time. You're probably thinking, well, where's the graph at? Well, it's distance versus time. So what do you remember? It's going to be C, speed. Okay? All right. So now let's go ahead into heat. Let's heat this thing up. The direct transfer of heat from one substance to another, that is touch. You're touching the object now. Okay? So both objects, right, are going to be touching. Conduction. Conduction is your answer. Number 2. The transfer of heat by the movement of fluid or air, heat rises while cold, okay, tends to sink. So there's a cycle effect here. Convection is going to be your answer. Number 3, the transfer of heat through empty space. It's not touching. It's not fluid motion or fluid movement. It would have to be radiation. There you go. Think about being on a beach, right? And you can feel that heat. The sun isn't touching you technically, right? But yet it's still reaching you, okay, through empty space. Number 4, identify B. So we're right here. What is going on? Okay, what would that be? Would that be convection? Would it be radiation? Okay, or would it be conduction? Answer is convection, because here you see the movement. Remember, look at the heat. Look at where the arrows are going. Yep, the direction is going upwards, but yet as it starts to get cold up here, what happens is it becomes much more dense and it starts to sink. Number 5, let's see if I can get you here. This time, identify A. Look at this. Empty space. Radiation is your answer. All right, we have three that you've taken care of. All electromagnetic waves travel at the same speed in a vacuum. However, different kinds of electromagnetic waves have different wavelengths. For example, microwaves have longer wavelengths than visible light. How is it possible for both microwaves and visible light to travel at the same speed in a vacuum if they had different wavelengths? I think I'm gonna get you here. So they have the same speed, but different wavelengths. There's something that has to be a factor. All right, you should be able to make some connections from the past lessons that we talked about with wavelengths and the properties. So is it A, microwaves and visible light have the same energy? Is it the waves of visible light have less energy than microwaves? Is it microwaves and visible light have the same have different frequencies? Or is it D, distance between point on one wave to the identical point on the next wave is the same for both microwave and visible light? Answer is C. What changes the whole game is this right here, frequency. Remember what we said, frequency is how many waves can pass a given spot. So if that changes, that can also cause or alter and cause both of those waves to move at the same speed. All right, number 2. The graph below compares that the waves that are part of the electromagnetic spectrum. What can you conclude about gamma rays from the data shown in this graph? So let's find gamma rays. We're going to be right here. A, gamma rays have the longest wavelength. Is that true? Gamma rays and X-rays may have the same wavelength. So here's X-ray. C, gamma rays and radio waves have the same wavelength. Or D, gamma rays have the narrowest range of wavelengths. So let's find out. Answer is, what do you think? It's B. All right, you're thinking, man, how's it B? I don't get this. Well, let's take a look at it. Gamma rays have the longest wavelength. That can't be true because where can we find that? There you go. Bada bing, bada boom is right here. Look at this, how long this is. If you compare it to this, you notice this is much shorter. But here's the trick. Let's say I superimpose this right here and put it over top of this. These are very close together, and that's why your answer would have been B. Okay, so pay close attention to the length here. Oh, double dose. Felipe was enjoying the sunny day at the beach, and he told his friend Carl that he was really enjoying the warm feeling that he was getting as he sat in the sun. Carl explained that the electromagnetic radiation was responsible for this warm feeling. Which part of the electromagnetic spectrum was responsible for making Felipe feel warm? Notice feeling warm. Gamma rays, microwaves, visible light, or infrared? Good job. It's going to be D. Infrared is going to be your answer. All right, here we go. Number 4. The graph below shows the wavelength of 4 types of electromagnetic waves. Which graph most likely illustrates a radio waves? So pay close attention to all 4 graphs. Think about what we learned. Answer is A. All right. Which one is the longest? It's gonna be A. And you can tell right here, look, crest, and you can't even find the other crest on the graph. Okay, but here it's a little bit tricky here, but these almost look the same. Okay. Visible light consists of electromagnetic waves that humans can see. Which color of visible light has the lowest frequency? Blue, red, violet, or yellow? All right, what do you think? There you go. It's actually going to be violet. So which color has the lowest frequency? And the way you know it is because it's going to be the furthest over here. So that one right here is going to be the furthest. All right, man, we're closing this out and I think I'm losing. The diagram below represents waves from the electromagnetic spectrum. Assume that the diagram above shows infrared radiation. How would a diagram showing X-rays be different? The distance indicated by D would be longer. The distance indicated by C would be shorter. The point represented by A would not be present, or the point represented by B would be at the top of each wave. It's going to actually be B. All right, so take a look at that one right here. See, so if you look at the question, all right, how would the diagram for X-rays be different? Okay, so the distance indicated by C, okay, right here, if you look at it real quick, this distance from crest to crest is going to be shorter. Okay, so that's how you're going to know you're focusing on the crest. Both information, radio, and television signals are carried by radio waves. What other type of electromagnetic radiation is used to send over long distances? So we're going to use this for over long distances. Let's see what you remember. X-rays, microwaves, gamma rays, or ultraviolet light? Answer is B. It's going to be microwaves. Okay, so this is actually what you use, and you can actually use this as well for cell phones as well. Okay. These graphs show different types of electromagnetic radiations. If graph 1 shows ultraviolet radiation, what type of electromagnetic radiation would graph 2 show? So let's look at this, okay? So you have right here, all right, if graph 1 was UV radiation, then what would 2 have to be? Is it infrared light, microwaves, violet, X-rays? I think I'm gonna get you here. The answer is going to be D. It's actually going to be X-rays. And the way you know, okay, remember the game, X-rays, okay, are going to actually have more of a frequency. The waves are going to be shorter. The other ones, infrared and microwaves, they're too big, they're too large. So they're not going to work. Okay, they're going to move opposite with the spectrum. All right, number 4, infrared and ultraviolet light are both parts of the electromagnetic spectrum. How is infrared light different from ultraviolet light? Only ultraviolet light comes from the sun. Only ultraviolet light travels at the speed of light. Infrared light has a higher frequency than ultraviolet light. Infrared light has a longer wavelength than ultraviolet light. So let's see what you guys come up with. Answer is D. Infrared light, remember, has a longer wavelength. So remember, when you're moving from radio is larger in wavelength. As you move to the opposite end, the wavelength becomes smaller. The frequency is actually going to become greater as you move to smaller waves. These graphs show the 3 types of electromagnetic radiation. If the graph 3 shows ultraviolet light, then which statement about the other 2 graphs would be correct? So pay attention now. Graph 1 would show X-rays. Graph 2 would show visible light. Graph 1 would show infrared light. Graph 2 would show microwaves. See what I remember about size of a wave. Let's see if you got it. There you go. It's going to be C. Graph 1 would actually show you infrared because it's much larger than the other ones. Oh, last column. Let's see if we can get all these right. When a material is heated, the particles within it have more energy and move blank than when it's cooler. Slower, A. Faster, B. C, at medium rate, or D, none of the above. Survey says B, faster. Remember, the more heat that you add, the greater the molecules will start to move. Number 2, what do these two magnets that are touching represent? Okay, so imagine, look at this red magnet and orange magnet. Okay, so now the red is being heated right here, and they're both metal and they're touching. Would that be conduction? Convection current is occurring? Radiation? Or none of the above? Hint, they're touching. Good job, is going to be conduction. Number 3, in a liquid and gases such as air, where the particles can move, heat energy creates movement in the liquid or gas called. Here's our movement now. Here's the heating, and it's moving. And I wonder, look at the color red, what that represents, and then blue sinking down. Maybe a little hint for you. Answer is B, convection. Very good. Remember what we said, as liquids start to heat up, they become less dense and they move up. But all of a sudden, as they get cold, they become more dense and then they sink. Heat energy can also be transferred through gases or vacuum by infrared, heating through empty space. Conduction, convection, radiation, or none of the above. So notice the heating action and notice the movement through empty space. Answer is C. Very, very good. Number 5, what type of heat transfer does the image 1 represent? So we're looking at 1. Man, I might want to wear a glove because that's pretty red there. Is it conduction, convection, radiation, or sublimation? Survey says for the last answer. Who will take it? It is A is gonna be your answer. There you go. Excellent, excellent job. All right, did you guys beat me? I don't think so. So let me show you what I'm about to do to you right now. So check this out. Stay tuned.